Hi, I'm Bret Barkelew. I'm ostensibly a firmware security engineer, although more and more I seem to do infrastructure and planning, but it's just how things go. When I was asked to participate in this talk, I was a little confused at first about what the firmware portion of it was going to be. It seemed like everything was pretty straightforward and that all the actual explanation would end up being on the services and woo delivery side of things. But as I talked to more people, it became pretty clear to me that there is a lot of noise in the signal. There's a lot of ambiguity. It's not aided by the fact that for a firmware person, this ends up involving a lot of things that have been clear to driver developers for a while, and they've been leveraging these facilities for quite some time. So when you end up talking to them, they act as though it's business as usual and there's nothing to see here, and why don't you know this? So from a firmware guy's point of view, there are a couple of things to figure out. But even within the firmware world, there are aspects of this that can be confused at first. It can involve up to 2 or more signing certificates. There are, at various stages along the way, there's multiple things that could be referred to as a payload. There is a GUID that ends up having to match in 3 or 4 different places, and it's not immediately obvious that those need to match. So I was hoping to use my portion of the talk to just sort of elucidate some of those things. So from a firmware perspective, these are the 4 steps to getting something on Windows Update. You need to create your payload. You're going to have some system files. This is where it sort of verges on driver world. System files that describe to Windows what node in the PNP system is being targeted with your firmware payload and how it should deliver it. You're going to have to take those deliverables and package and sign them. There are 2 different processes that can be used for this. There's the recommended way, and then there is the other way. The recommended way is to use HLK and do a full test pass on a target system. The other way is to do an attestation signing of just basically a package. And then there's finally like going to the Dev Center and publishing it on Windows Update, which Keith will refer to a little bit more. This final note is kind of shoehorned in here. Mike wanted me to mention that while this is a recommended process to go ahead and start using for your firmware updates, it will be required for Win 10S.
And 10S is Windows, it's 10S, but now we've changed the name to Windows 10 in S mode.
Okay, you heard it here. So like I said, I thought a useful thing to talk about, at least in my slides, and I'm happy to go into way more detail in the Q&A, is to try to clarify what a capsule is, what goes into a capsule, what we're referring to at various stages along the way. Because there are various points of this process that require GUIDs, there are various points in this process that require identifiers, version information, signing, so I'm going to talk through a couple of those right now. So the first step is to start with a binary payload. This is what ostensibly you're trying to deliver to your firmware driver to be placed in wherever it's going to go. For UEFI firmware, this could be your firmware volumes. If you're updating an in-system component, this could be the firmware payload that you intend to deliver to the embedded controller. For a sample we released over the summer, this could be a TPM firmware. But this is ultimately the stuff that you wanted to get on the system. As an optional step, if you're using the framework that we contributed through our GitHub, and honestly, if you're using the tools that I'm going to mention in my last slide, a lot of the tools refer to this process. There's a capsule handling framework that we published that handles making ESRT registrations for you. It handles a bunch of capsule sort of pre-processing before you write it out. The idea being that if you're using that stuff, by the time you get a payload, all you have left to do is save it wherever you were trying to save it. But part of that pre-processing is wrapping it with these header structures. So I encourage you to take a look at what's available there, but I won't go into a whole lot of detail here. Suffice to say, there's a layer on top of the payload that describes what the version is, what the LSV is, and a couple of other fields that you might want to specify. The next step is to sign it. Now, this is the signature that is going.
Describe what they're doing on the site. He's actually building it. If you look on the right-hand side of the screen, what he's been doing as we progress through the slides, he's building the capsule around the payload.
Okay.
Sorry for interrupting.
So the next step is to provide a signature for the Capsule framework itself, because the Capsule framework is just going to be handed a binary that was sent down from the OS, and we don't want to just trust whatever binary was handed to us. So the signature that's used in this instance is going to match the public key that is inside the FMP driver itself. This is not the signature that you're using to attest to your identity when you're uploading it to Woo. And that has been one of the points of confusion as I've talked to people. So at that point, there's an EFI layer that you'd want to wrap around this so that you can sort of indicate that you intend to process this as a firmware management protocol capsule rather than just a standard UEFI capsule, which has its own implications. This is the first time that you're going to actually use a GUID to identify what kind of capsule this is. This GUID is the one that is registered in your FMP protocol driver. It is the one that needs to be published in the ESRT. It is the one that will end up in the INF file, because this is basically the targeting GUID. You're saying, I have a firmware payload and it is targeted at this kind of a device. And it is how Windows identifies what you're going to hand it to, and it's how the Capsule framework identifies which driver to pass it to.
And how Linux does it.
Sorry, what? And how Linux does it. Sorry. Apologies. And then the final step is to turn it into a UEFI capsule, which is to use GenFV to wrap the payload in a capsule wrapper. This is the actual wrapper that tells the system whether or not a reset is going to be required to process the capsule. It tells whether it needs to be persisted in memory and a couple of other things. There's another GUID here, but it is not sort of an arbitrary GUID. The GUID that's used here is a fixed GUID to indicate that the next layer down is an FMP payload and that it should be processed through the FMP framework. And finally, you have a binary payload. This is the payload when you get to the sort of the driver-facing level, the Woo world. This is what they're referring to as the binary that you need to be able to sign to deliver it through Windows Update. This binary will be paired with its INF file, and it's optionally a cat file, which I'll talk about on this slide. The next step is to actually get the files, the collateral together that you intend to publish to Windows Update. We've provided a tool to create Windows capsules. It will generate an INF file, which you pass it the payload, but it doesn't actually operate on the payload. It's not creating a new binary. It's just using effectively the binary name to associate that name with the INF file. The utility as provided will create a cat file, which is not necessary if you are doing the cab file, the attestation signing of the cab file, but it is necessary if you're going to do the HLK validation.
Not necessarily. You don't. For the validation portion, all you need is the INF and the binary. We will give you a cat. We throw away whatever cat you give us and generate a signed one. So.
Yes, the tool does expect you to provide a signer. This is not the capsule binary signer, or not the FMP signer. This is a test signer for your operating system, so that if you're going to right-click the INF and say install, that's the signer that it's going to use. These are the tools that I mentioned and referred to. Mike wanted me to clarify that they do have a prerequisite, if you want to call it that. There are certain parts of these tools that expect you to have already installed either the Windows Software Development Kit or the driver development kit. The reason is it references things like INF to cat to make the cat file. It references, if you're going to use the attestation file signing, it references make cab. And there's just a couple of small utilities that it expects to be there. We call that out in the README, but I wanted to call it out on this slide. That's pretty much it. I wanted to leave plenty of time for questions.
So My name's Keith Kepler. I'm a PM in the strategy and ecosystem team, and I handle the driver servicing side of the ecosystem. So I'm here to just chat with you about driver updates. So this is a firmware area, so we're going to concentrate on just the firmware update capsule piece and walking through parts of the hardware dev center and Sysdev worlds that you may have had to experience. So there are two flows right now available. We're in the process of migrating all of the items that are on Sysdev to hardware dev center. But the stuff that's left on the Sysdev portal is for if you need to sign your EFI binary. That's it. That's the only thing that's up on Sysdev. So don't use it for anything else other than if you have to sign your EFI file. So you'll I have a screenshot here of where you'll click. You just do a file signing, upload your file.
And we wanted to call this slide out because we've had a lot of confusion in the folks who are responding to questions on if this is a firmware update or is it .EFI. We have a lot of people who don't know, so we've had people redirected to this page unintentionally. We're pointing out here that you do not need to go to this page for a firmware update.
Right. So on the hardware dev center side, so how many people have used hardware dev center to do a firmware update capsule? Nobody? Really? So this is all very new to you. This is why the driver developers are like asking you guys, well, why don't you guys know how to do this? This is like what we do daily. So how many have a hardware dev center account? 1, 2. Okay, 3.
Yes. It's a Linux guy too.
Yeah. So I have some bad news for the rest of you. If you want to do a firmware update capsule posting to Woo, you got to get a Dev Center account. Hardware Dev Center account is required. Not only is that required, but you have to have an EV cert ready to be, like, you take your cert, you upload it, the thumbprint is copied into the Dev Center, and that's how we say, yes, this is the package you signed. It matches the EV cert's thumbprint that you signed your cab or your HLKX package with. So that's the only use for that EV cert, right? So when you use that EV cert to sign the cab or to sign your HLKX package, that's it. That's all that EV cert's used for, to validate your identity that you uploaded this package and it didn't get hacked and cracked before it got to us. So you got to get a hardware dev center account. Once you have a hardware dev center account, you'll go to the hardware dashboard. Once in there, you will click the submit a new hardware. And this is where the fun comes. So this is where you're going to drop your HLKX package that has the tested firmware update capsule. Or you're going to drop your cab file that just is the INF, the bin, and you don't have to include your cat file in that.
If you haven't generated an HLKX file previously, that's a whole nother session that we're not even going to talk about today. It's the hardware logo kit, and it's a client-server testing scenario that is how do I say this? It's
the certification kit. So you use it to get your driver or anything certified. It's just a bunch of tests that we run. On firmware, there's not that many, so it doesn't take too long, but there are a few.
And you're going to have to set that environment, maybe not you, but you have somebody set that environment up, run the test on a server with, or a system with the updated firmware, and then submit that to the hardware dev center.
Yeah, that's if you want the firmware to be certified. Doesn't necessarily have to be certified to be posted to Windows Update, or to actually get a firmware update capsule signed and gotten back. The cab file that you get back is what we called attestation signed. This is basically you are attesting to the quality of the submission that you made and that there aren't any problems. We give it a slightly lower production quality signed signature, and you can go on your merry way and test and post that to Windows Update if you needed to. Most of the OEMs, though, if you're doing work for them, will be requiring that it be certified before they wanted to be able to take it, though. So we automate this. When you drop a cab, it goes down the attestation path. When you drop an HLKX package in there, it goes down the certification path. So there's no choices that you need to make here. Just drop the file, whichever type you want, and you'll get the signature that's offered through that path. Once you've dropped the file there, we go through a signing service. It doesn't take a bunch of time for firmware to get it signed back. You will get a progress bar when it gets to the finalized thing. You can download your signed package by clicking on the More button. It says less now, but it would be More. And then there's a download your signed files. This is the INF, the bin file that you had, and your signed catalog file that's signed by us. If you want to install it, you can just like right-click on the INF and pick Install, or you can go to Device Manager, right-click on the firmware area, and update the firmware driver that way. And then it'll kick off the UEFI update mechanism that's part of Windows.
Passing it to update.
Yep. So now we got our driver, it's signed, and we want to now publish it to Windows Update. This is the bulk of the problems where a lot of issues can come up. One, you need to make sure it's called a shipping label that you will create. You will create this shipping label. You will then actually select whether you want it to be published to Windows Update or you want to share it with an OEM or ODM or another partner. And that's where you can specify the actual name that's in a list that gets populated. The next thing you're going to do is highlight it. What we do at that point is we look at your INF and we say, what are the hardware IDs that this is applicable to? Well, we look in there, we generate a list down below, that's number 3. You have to choose which ones you want to publish to. So you'll pick, it'll probably be just 1 or 2 in there. You pick that one if you want to publish to it, and then you will click the Publish button. Hitting that Publish button does not actually publish it. It just moves you on to the next phase. We should change the button to say something else, but it says Publish. You're just selecting which ones you want to stage for publishing. In the 4th box, once you have clicked Publish, we light up the CHID targeting information. This is required for all firmware postings on Windows Update because we do not want your firmware going to somebody who it shouldn't be, even though it may have the same hardware ID. So we require you to get the CHID from your computer manufacturer that you're giving it to. They will have that information, they can provide it to you. This is where you'll enter in, it's just another GUID or hash. And you will add that CHID to your box there, and then at the very bottom, there's a Save button, Publish button, the real one. That's where, after that part, it will go out and we will start our internal process on it. Right now, we have with the Spectre and Meltdown virus stuff that's going on, we have a hold on almost all firmware. So if you don't want your firmware held on for a long time, if it doesn't have any microcode updates in it that are for this, you can contact Microsoft via the Hardware Dev Center support mechanism, and then we can say, okay, now we'll release this firmware. But as of now, all firmware that's being published to Windows Update goes through our flighting program. The flighting program is if you have joined the Windows Insiders program, you are getting the pre-release builds. All of those folks are where we flight our drivers to. We don't flight it to the retail population. If you've signed up for driver flighting, that means you are giving us the permission to push these test drivers. They're production, but we want to test them in the market to see how are they doing. Are we getting P&P install errors? Are we getting other errors? And if we see a lot of errors, we will reject the submission. We won't actually let it go to the retail Windows Update population. If it passes all those metrics, then we let it go through, and it goes through the retail population, and then everybody has access to it. That's where it's sitting at the Microsoft approval stage in your little bar that you see right here. So the Windows Insider programs, do you want to talk to that, or do you want me to?
If you're okay.
Sure. So if you're not familiar with it, just windowsinsiders.com, and get you signed up. if you do have your firmware pushed to the Windows Insider program, if your machine is joined to the Windows Insider program, then you can actually start getting your firmware much sooner than having to wait for the others to get published to retail, because now you're going to be in that audience that we're targeting that driver to. So this is just a quick sign up, insiders.windows.com. That's basically it. There are a couple of items about the Windows Insider program. The rings, basically how dangerous or how often you get updates.
Test pool.
Yeah, the test pool. So it goes Microsoft rings. We are the ones that we get daily builds, and those are kind of scary sometimes, but you know, daily builds. Then there's the Windows Insider Fast. This happens usually at a once a week or once every other week kind of cadence. Then the Windows Insider Slow, that happens on a much slower 3, 4, every 5 weeks, they'll get another build update. And then there's the Release Preview. Release Preview is basically a Patch Tuesday pre-release build. So you're on RS3 or the current generation of the product, and you are in the ring that tests the next Patch Tuesday build 2 weeks before it gets released. And that's what the Release Preview ring is. So all of those folks are, the drivers go through the various stages, Microsoft rings, Insider Fast rings, slow rings, and as the driver looks good, we progress through and each one. And then once they look good on all of those, that's when we release the firmware.
Can we touch on optional DU and CU?
Sure. So when you publish your driver or firmware update capsule to Windows Update, there are 2 checkboxes that can be available for you. Automatically, they are not. So when you publish your firmware, it will be optional, which means it doesn't get pushed automatically to anybody. Everybody that wants that firmware will have to actually go and dig for it via Device Manager, right-click on their firmware and say, are there updates? So that's one way to get optional drivers. The other way is if the OEM grabs the driver and posts it to their website. Automatic and we call them automatic updates. There are 2 types. There are critical, and then there's dynamic updates. The critical updates are ones that come down during your off business hours settings, so that every night we run Windows Update. Are there new updates? If there's a critical driver update, that's the time we send it down. For the dynamic updates, those ones come during updates. So when you do an upgrade, and we are upgrading you to the new version of the OS, and we say, oh, this driver that's on your system has a problem with the next version. We need you to have these other version instead. We stage those on the system before we get to the first boot, so that you have the driver on your system. So that's what the dynamic update is. That one is only for when you're doing the upgrade scenarios. So critical is basically the one that you're going to want to set it at. You don't want to do firmware as a dynamic update. You wouldn't want to do it during
Critical
the update.
or optional. Optional is
Yeah.
if you want to be able to tell people it's there.
The only way that you're going to get that automatic option, those 2 checkboxes that are available, is if you sign up for driver flighting, and that's your Dev Center seller ID has to do that. So up on the Dev Center dashboard help documents, there's a driver flighting sign up page that you can sign up, and then it would light up those 2 automatic checkboxes. And that's it.
We really wanted to bring this to everybody's attention because honestly, we don't think a lot of you folks are going to have to run into this or are just starting to run into this. The reason we called out Windows 10 in S mode, we being Microsoft are looking at ways to ensure that the operating system is more secure. We think that this is one of the ways that by pushing firmware updates through Windows Update, we can keep this in a more secure fashion, and getting these updates to come down regularly in update systems, for example, post Meltdown and Spectre, would be a way to get to that point, right? Get to the goal. Do we have questions?
And just a time note, we've only got about 4 minutes, so
Okay.
we'll have time for 2, maybe 3 questions, depending on the level of detail.
So the only way to push a capsule coming Windows 10 S mode is via Windows Update?
Yes. Well, so there's, let me clarify that. Windows S mode does not allow you to run EXEs. So running that BIOS updater utility you want to run doesn't work. If you have a firmware update capsule package, you can update that 10S system however you want with that package. It's an INF, it's a cab, or it's an INF, a cat file, and your bin file. We have signed those. You can install that however you want on that system, and we allow it. So the best way is via Woo, because it's offered automatically, or if you had it via an OEM website, the OEM would have to have the firmware update capsule in a unexpanded, you know, INF cab and bin file.
I had a question about the CHIDs. How are those intended to be used for option ROMs?
So option ROMs, are they going to be using the firmware update capsule, or are you going to be, aren't you going to be like incorporated into other stuff, or are you going to, no?
No.
That's a good question. I don't have an answer for the option ROM side. I'm thinking more of like you have a system BIOS.
Isn't it that when they select it as a upload as a firmware, that it's going to prompt up for the CHID targeting, which is just the installation or distribution targeting?
Right. Right. Yeah, but he won't know. Yeah, he's an option ROM. It doesn't go to a specific vendor.
Okay. So,
yeah.
okay.
I understand.
That's
a good question. I don't have the answer for you. I can get back to Michael, and Michael can send it out to the group.
I think today what we say is the expectation is that your kernel driver would be pushing that, at least in the, that's what we have in our existing
That's what I thought too, yeah, but I didn't know.
Because then your video driver would generally target, right, your video card, or the OEMs would, if they change the vid PID, they would do that, and then that's how you would payload it. But if that's not supported, we should chat about the other routes that we might use.
Sure. Anyone?
So it looks like for the most part, everybody's got to sign up for a Dev Center account if you want to start doing anything on posting the Windows Update. That's priority 1, I guess.
Thank you.
Thanks, everybody.
All right, thank you.